children here, this model is fairly inaccurate. But as we continue with height, it becomes more accurate right here. Of course, it's eventually going to be very inaccurate because as you get taller, well, you pretty much don't get much taller than about, what, 6 to 7 feet, some people at the most. So this line is going to continue off into infinity, and the human condition is going to turn here. So we will have big problems past childhood. But we're just looking at children right now anyway, so it's okay. I see problems down here. I see pretty good match up here, which is to be expected because the better line of fit or better curve of fit would be something that went up quickly and kind of leveled off because that's the way the human body tends to grow. It kind of advances quickly and then sort of everything tapers off at its own pace. But we're using linear regression, so that's what we get. All right, and from here, I think there were some questions that it asked. Let's look. Use a graphic utility to draw the scatter diagram. Done. Use the graphic utility to find the line of best fit. To answer that question, you would put in this equation as your answer on the test. Okay? How will I know you find the line of best fit when I can't look at your picture? Because when you write the equation, y equals to mx plus b, you have the right slope and the right intercept. I can know you must have found that because you aren't finding this by yourself. Guarantee you that. I know that. So I would like to go to y equals and actually put mine in, my rounded version here. 0.37x, this is just for fun, you guys, plus 733. This is the rounded version. When we hit graph, you'll see the rounded version is not exactly the same as the other one. It's off by, well, I would say, you know, a good 100th or so. Not too bad though. It's not very far off, but it is off. This was the second line I put through here using the approximated version. It still does a fairly good job of modeling the data, if anything. So, anyways, go to y equals and clear that out. We don't want that on there. I was just seeing what would happen if you cleared it. That would be good enough for me. So I could use this as your answer to the question. Can you find the line of best fit? Well, then you find me the slope and y-intercept, right? And write the equation out. All right, now the question asks, predict the head circumference of a child that is 26 inches tall. Is 26 the x or the y value? X. So that means you go to second, calculate a value when x equals 26. Oh, gotta wait for that. 26. And you read the y value with child, according to this data, has a head circumference of 17.03. And then the other question says, what if the what is the height of a child who has a 17.4 head? How do I do that? That's the y value, so I need to put that into the y equals. So y equals 17.4. You hit graph, and you'll see that line represents all the 17.4 values, and we want to find out where our model hits it. So how do we find that? Second, calculate the intersection. You really, honestly, you can be far away from it, but I'll just move pretty close and hit enter 3 times. 1, 2, 3. And according to this model, a child who has a 17.4 head circumference would be 26.97 inches tall. Okay. Do you believe this model? Do you believe that our line represents what's happening here with the data? Give me some of your concerns. If you were an insurance company and you had to insure the size of a child's head, would you trust this model? I would not trust this model for a variety of reasons. What's the most obvious reason why I wouldn't trust this model? That's what I'm looking for somebody else. Particularly that, because why is the base so bad and the other part so good? How many kids are we looking at here?
You have the two on the side that's messing with all the rest of us.
Just 9 kids. way too much variety. We should be looking at 900 kids to get a good accuracy level here. Okay, at 9 kids, you would never expect a model to be anything worthwhile in a practical sense. This is not a practical setting. This is, can you use the calculator to represent data and giving you something to talk about. So in the future, if you ever see this again in a stats class, remember that your sample size has to be sufficiently large enough to represent the population. 9 kids hardly represents the 9, I don't know how many, some million kids that are out there. I haven't looked at the census in a while, but I know that's pretty big. So that's one thing. Another thing too is the error here is too great on this lower part here to really give an accurate reading. You can see the error is great there. You would probably want to try to run some kind of regression through this other than linear to see if you can get a better fit. Those are discussions for another day. Because the goal of today is, can you get this data onto a scatter plot? Can you get linear regression on there and answer a few basic questions? Okay, so what I want you to do is with the remainder of the 3 problems, I don't have the answers to them, but I will go over them on Thursday. Make sure you can get them to work for all 3, and I would take the time to do it. Because we don't need to be stumbling over the calculator when we're trying to answer questions on a test about what type of regression to use and what the questions are. So that's your task. Have fun. See you on Thursday.